Good afternoon and welcome to our class. Our topic for today is all about the nature of the roots of a quadratic equation. But before we start, let me share with you our learning objectives. First, to determine the discriminant value of a quadratic equation. Second, to characterize the roots of a quadratic equation using the discriminant value. In the quadratic formula x equals negative b plus minus square root of b squared minus 4ac over 2a, b squared minus 4ac is called the discriminant. This will be used to determine the nature of the roots of a quadratic equation, whether they are real, non-real, equal, unequal, rational, and irrational. The following are the key concepts that we need to characterize the nature of the roots of a given quadratic equation. First, when the discriminant value is equal to 0, then the roots are real, rational, and equal. When the discriminant value is greater than 0 and a perfect square, then the roots are real, rational, and unequal. When the discriminant value is greater than 0 but not a perfect square, then the roots are real, irrational, and unequal. When the discriminant value is less than 0 or a negative number, then the equation has no real roots. Now, let us apply the key concepts in characterizing the nature of the roots of the following quadratic equations. So we have to determine the discriminant value and characterize the nature of the roots of the following quadratic equations. Number 1, we have r squared minus 10r plus 25 equals 0. Number 2, 2w squared minus 4 minus 7w equals 0. Number 3, n squared minus 7 equals 0. And number 4, we have 3x squared plus 2x plus 5 equals 0. For number 1, we have r squared minus 10r plus 25 equals 0. Using the discriminant formula b squared minus 4ac, first, identify the value of a, the value of b, and the value of c. With the given quadratic equation, the value of a is 1, the value of b is negative 10, and the value of c is positive 25. Using the discriminant formula b squared minus 4ac, let us substitute the values of a, b, and c. So we will have the discriminant value is equal to negative 10 squared minus 4 times 1 times 25. So here, negative 10 is the value for b, and positive 1 is the value of a, and 25 is the value of c. Simplify, negative 10 squared is equal to 100. Negative 4 times 1 is equal to negative 4. Negative 4 times 25 is equal to negative 100. Then 100 minus 100 is equal to 0. So the discriminant value of quadratic equation 1 is equal to 0. Since the discriminant is equal to 0, therefore the roots are real, rational, and equal. For number 2, we have 2w squared minus 4 minus 7w. Since the given quadratic equation is not yet written in standard form, we have to rewrite the given quadratic equation. So the standard form is 2w squared minus 7w minus 4 equals 0. Then identify the values of a, b, and c. For the value of a, we have 2. The value of b is negative 7, and the value of c is negative 4. After identifying the values of a, b, and c, substitute the values in our discriminant formula, b squared minus 4ac. By substitution, we will have negative 7 squared minus 4 times the value of a, which is 2, times the value of c, which is negative 4. Then evaluate. So, negative 7 squared is equal to 49. Negative 4 times 2 is negative 8. Negative 8 times negative 4 that will become positive 32. Then, 49 plus 32, that is equal to 81. Since 81 is a perfect square and greater than 0, therefore the roots are real, rational, and unequal. For number 3, we have n squared minus 7 equals 0. So, identify the values of a, b, and c. The value of a is 1, the value of b is 0, since we don't have any linear term in the given quadratic equation, and c is equal to negative 7. After identifying the values of a, b, and c, substitute the values in our discriminant formula, b squared minus 4ac. So, discriminant value is equal to 0 squared, 0 which is the value of b, minus 4 times the value of a, which is 1, times the value of c, which is negative 7. Then, evaluate. We will have 0 squared is equal to 0. Negative 4 times 1 is negative 4 times negative 7. That will become positive 28. So, 0 plus 28 is equal to 28. Since the discriminant value is equal to 28, which is greater than 0, but not a perfect square, therefore, the nature of the roots of the given quadratic equation are real, irrational, and unequal. For our last example, example 4, 3x squared plus 2x plus 5 equals 0. Identify the values of a, b, and c. So the value of a is 3, the value of b is 2, and the value of c is 5. After identifying the values of a, b, and c, substitute the values in our discriminant formula b squared minus 4ac. So the discriminant value is equal to 2 squared. 2 is the value of b, minus 4 times the value of a, which is 3, times the value of c, which is 5. Then, evaluate. Discriminant value is equal to 4 minus 60. So, 2 squared is equal to 4, and then negative 4 times 3, that is negative 12. Negative 12 times 5 is negative 60. Simplify 4 minus 60, so that is negative 56. Since the discriminant value is less than 0, or it is a negative number, then the equation has no real roots. For your synchronous activity, determine the discriminant value and characterize the nature of the roots of the following quadratic equations. Number 1, x squared minus 3x minus 5 equals 0. Number 2, x squared equals 5x minus 11. Number 3, 3x squared minus 6x plus 3 equals 0. And number 4, x squared minus 4 equals 0.